All right, looks like we're live. Welcome everyone to the second cluster add-ons meeting. We've moved the meeting time. I hope that works better for everyone. And I also had a brief look at the minutes document, so we didn't have any big actions from last time, so we're good there. If you have any agenda items, please add them to the doc. For now, I only see
we need to open up the permissions on the document, I believe.
Oh, really?
I believe so.
There's like 9 or 10 people viewing it. I can take a look at it. I'll see what I can do.
On my personal Google account, I have edit access. So it's not public, but maybe the working group members have edit.
Yeah, it looks like Kubernetes SIG cluster lifecycle Google Groups has edit access.
Let's see. Okay.
The documents, we normally make them public read-only and then edit with the Google Group.
Oh, I actually did not know that. I thought they were open. Cheers.
Yeah, that's something I was wondering. Is it correctly set up? I wasn't quite sure if I needed to do anything more. Is it good the way it is, or do I need to do anything?
I think it looks correct, but but please speak up if not.
Okay.
If you can't edit, please do try to join the Kubernetes SIG cluster lifecycle Google group, and it will take probably about a minute or 2 minutes to replicate around the world, and then you should have edit access.
Right. Okay. Yeah, we wanted to take a look at the core DNS operator. That's what we decided the last time, that it would be a good first example to work on. And Justin prepared some code for it. Is anyone else who's been working on this or has like a general approach or ideas to share? But I think Justin can go first in any case.
Yeah, I'm going to go first. I mean, yes. So the idea was to get the ball rolling, right? So I feel like so I put up a first one based on some work I think Jeff and I have done in the past. So Jeff, you will probably recognize a lot of the code, and this one.
Maybe you can just generally explain how you went about it. So I might take a look at this later on again and then try to distill or see is this a general approach that people could take? Is this something that we could prescribe to people no matter what toolkit they're going to use? So we have some docs. So be a bit more verbose if you can.
Yes. Would it be helpful to share the screen so we can actually look at the PRs as the code as well? Would that be good?
Yeah, please do.
Let me see if I can make this work. Okay. So I think that is sharing the correct.
Super. Yes, that looks good.
Okay. So there is a lot of boilerplate here, but the actual idea is that we basically build an operator. I had some notes on things which I thought were most interesting. Oh, it's not letting me click. All right. We build an operator for core DNS. So if I do kind core DNS, you can see that we have for each add-on, we are proposing, or this method has a CRD, a dedicated CRD for each one. I'm highlighting the things which I think are most controversial here. And then the idea is that then there is a controller that is built with Kube Builder, which is a sort of, I don't know, a framework or a tool that creates operators, sort of scaffolds them out for you. So this is the sort of commands for building the Kube Builder controller. Jeff and I have done some work previously to extend Kube Builder to better work with the declarative case, which is often the case for cluster add-ons and the like. And what that means is, so Kube Builder will typically create a reconcile. I don't know, I think we might have lost the reconcile method, but we'll typically, with Kube Builder, you get to a point where you have to implement a reconcile method in Go code, and you're basically left to your own devices. And the approach here is to say, well, you want to declare or define the The add-on itself, you would prefer to define that in YAML, presumably. And so we have a fairly standard approach where we read a YAML file from a source. Currently, it's on disk. It can also be the cluster bundle or an HTTPS website or really anywhere. And then we essentially massage it and kubectl apply it. And that massaging is a sort of pipeline where you can do more or less whatever you want, because you are in, here's sort of the standard pipeline. So you can see that this is the actual body of the controller or this is the function, this is the file that KubeBuilder has generated, which we have then edited. And we have this reconciler. So this is pretty much standard KubeBuilder boilerplate, except that now all of our logic is in this sort of reconciler, which is a sort of standard reconciler pipeline where we do a series of transforms. So we add some labels, we set the owner ref, we go and look at some other labels, and we update the status to reflect the status of the add-on that we are deploying back into the CRD. We also, for the particular case of CoreDNS has some more specific requirements. It is not a simple kubectl apply, because you have to replace, in theory, two variables, the cluster DNS domain and the IP address, which you want to use for the kubedns service. And so you can see that here we're using string replacement to do that. We could also use, like a patch or other type, any other mechanisms like that. But we're still in Go code here, so we can do pretty advanced things like finding the DNS cluster IP. You can do that by, the convention is that the Kubernetes IP is .1 in your service CIDR, and the DNS IP is .10 in your service CIDR. And so that's what this logic implements. It basically goes and looks at the Kubernetes one and then changes it from .1 to .10. And it's pretty proof of concept code, as you can see, but it basically gets the right answer. So it's good enough, but you can make that logic as complicated as you want. I think one of the interesting things is whether these things should in fact be automatically discovered, or whether we should start to define fields, because of course it is a CRD. And so if I bring up the actual spec itself, you can see here that we do have a spec, but it actually doesn't have any real fields of its own yet. But we could in here have, the IP address to use for the service, and we could have the DNS domain, the cluster DNS domain to use. And I think that's an open question as to whether we should try to make the operators magically infer it, or whether we should have it be explicitly controlled. These two fields.
Do you have an opinion with how config should be managed with that regard? Would the core file be a string field on the CRD?
I'm sorry, can you repeat? Would the which file?
The core file, the core config for CoreDNS.
Oh, I think we should discuss that. I don't know. I think, honestly, I don't know. It's not a Kubernetes API, right? So it is let me just quickly, so these are the two fields. So we have this common spec, which defines the common things like the channel, and the common status, which defines the health. If we have a look at why we're doing string substitution, it's because there's that core file, right? And this is core file embedded in the YAML manifest. So this is the 131 YAML manifest for CoreDNS, downloaded from KK, from the cluster add-ons directory, which hopefully we'll get rid of. And yeah, this core file here, you can see that this would be hard to use a kubectl patch, right, or a customized patch on. It's a sort of different world. It's a different syntax. There's that DNS domain we have to plug in. So we only need to plug in the DNS domain. So that's at least one good thing. And I don't know how many people actually change a DNS domain, but one approach could be to write a CRD that abstracts that maps the core DNS configuration.
To like JSON, basically.
Yeah, JSON or YAML, exactly.
I mean, I'm pretty certain this isn't too different. I mean, there isn't much more that you could do in this thing that you cannot do in JSON. I think it's probably maps to JSON or YAML. There's got to be a mapping.
Yeah. The other thing is we can add that functionality. If we did a CRD or something, we can add that functionality later when we need it. It's nice. Like, I don't know whether these things are considered whether core DNS would consider these things implementation details. Like, Prometheus on 9153, that has to match presumably some annotation. Otherwise, it's not like you can magically just set that. Yeah, you have to like set some other stuff. Yes, the port annotation there to get the correct port. So it's not like you have free choice on all of these things.
Yeah, but it is also potentially possible that we could say like, there is the CRD exposes a subset of this functionality, an opinionated subset of some sort, like just expose a set of high-level parameters that may matter to a user in the typical scenario, and then we can evolve from there and
I think that makes sense. I think that's sort of the way to do it, is that if we have a core DNS CRD and we decide that the DNS domain should not be automatically discovered and is something we want to let people set, then yeah, we could have a field on there that lets you set it, and we would like generate the core file for you. And then if we later decide, oh, we do want to allow like generic core file customization, maybe we build a CRD, maybe we support patches against the CRD in the core DNS CRD. It's getting complicated to describe, but I think that the incremental approach probably makes sense here.
And there could be a possibility to like, instead of using the config map, having this as a string field in a CRD, right? Just so that it's in the same place, there isn't a separate object to it. You just say, okay, well, here is the core file for this core DNS thing, and that's as a string, and that it's taken as is. Or you have an option to kind of have a high-level thing over it, which is native to the CRD. I think those are a few things that we could sort of explore. Yeah, I mean, just a brief note. I don't know. How do you feel about the overall verbosity of the amount of generated code you basically have in here? Is there some better option that we could discuss down the line? I mean, I just worry that anybody looking at it who is not familiar with it will be like, oh wow, I need so much code to just like run this thing.
Yeah, I think that's a fair point. I think that there are currently some, or the way I wrote it up, there are some manual steps in terms of those, switching from the kube builder to the declarative pattern that we're using. We are aiming to get those into kube builder itself. So if we like this approach, it will be easy to generate that code. Kube builder itself is a little, like, it does generate a little bit more code than I would like to see. The actual controller is very small, right? The actual logic itself, like this is the entirety of the meat, as it were, right? So, it's some RBAC rules, which I also don't like, but that's a separate issue. That's effectively the boilerplate, and we could probably reduce that a little bit more. And then we have some this defines what our operator does. So it's actually very small. And then we have the actual logic to actually do the specifics of core DNS. So the code itself is very small. I'm not wild about the extra code, but we can tweak it a little. There's not. It's sort of just the way it is, I think.
So
when we talk about this, or when we show this pattern, it's important to show okay, here's the first commit, and the first commit is these two QBuilder commands. So sort of ignore that as a baseline, and then the diff on top of that being, okay, here's the actual controller implementation, and that's where we see it be more like 100 lines or less of code. I think
it's split up that way.
Grasp.
The patch has 7 commits.
Nice.
I guess I'm also wondering, like, because I did hear there are other things in KubeBuilder, right? Isn't operator framework is another thing that isn't operator framework another thing that is similar, that offers similar kind of functionality that KubeBuilder does, or does it not?
I put that on the agenda for after Justin is chatting. Yeah.
And I did see a few other things on GitHub previously. Okay, cool. Well, and the other point was kind of like whether, if we do run with a particular solution, say KubeBuilder being the preferred one within this group, then do we think that we can drive development of that solution in the future in a direction that would be beneficial to us, and etc. How do we feel about that at the moment?
Yeah, I mean, KubeBuilder is a Kubernetes project, and they seem open to changes. They've asked that they are very much focused on their stability guarantees. They're trying to be a stable API, but what they've compromised on is they've given a new repo for the declarative pattern, which is the one we're using here. So it's a slightly awkward import name, but you can. Oh, I can't scroll right now. Anyway, there's a different GitHub repo where we're able to basically do a lot of stuff there. So I feel like we certainly can do that, but we absolutely should look at the other options as well.
And does this generated code situation generally come down to like limitations of Go and how far you can go with the type system at present, lack of generics, etc., or are there any other things that one must keep in mind while thinking about this? Because I mean, I maybe was aware previously, but maybe not. I don't know. I mean, I tried KubeBuilder once and was like, "Oh, what did it do? And what am I supposed to worry about here? What am I not worrying about?"
There is some structure, I think, which KubeBuilder gives you, which adds a lot of files. So the sort of, this is the meat of it. So every controller, for example, is in package controller, and then they have this add name, which creates this adder function, and then they have this package controller, which goes and loops through those add functions. And so your actual controller itself is in package controller name, and there's the controller itself, and that's easy. But a lot of the weight or a lot of the number of files comes from this add to manager bit. And the reason that they do that is because then, rather than your main function, you're listing all the controllers and APIs, they have this trick where they're able to do like this add to manager function, which goes and loops through all those functions that have been added. Now, I think that it's great feedback that that's a nice trick, but if maybe it'd be better just to be more explicit and have a list of the API types, right? If we got rid of half the files, maybe that would be nicer. But anyway, let me call attention to one thing which I actually am generally unhappy about with this whole approach, and I'm hoping that maybe Operator SDK has a wonderful solution to this, but RBAC, the operator, because it creates a service account for core DNS, in order to create a service, because it's creating the core DNS, everything. In order to create a service account, I have to have permission. If I'm creating a service account, I have to have the permissions in that service account, which means that the operator's service account itself needs to have all the permissions of the thing it is deploying. So in this case, core DNS, for example, watches, get list watch, endpoints, namespaces, nodes, and pods. And so we need all those permissions. In this case, that's not a particularly egregious RBAC policy, but it's a little annoying to sort of have these policies roll up.
Yeah, so that's sort of the TLR problem, in one way.
Yeah, I don't know if anyone has an answer for that, but yeah, that was like my other thing I wanted to definitely call attention to, and get on the agenda. But yeah, that is I guess our first straw man.
I guess, I mean, one sort of, to me at least, one obvious point to consider there. What if our operator didn't actually have a thing in the cluster, and it was like a client-side thing? And as a client-side thing, it would be subject to whatever level of access that you as a user have. Like whoever runs it has certain permissions, and I mean, in similar vein, like the Tiller problem was solved by moving thing into the client side.
So, and just to clarify, we only have half the Tiller problem, because the other part of the Tiller problem is that it has a non-Kubernetes fronted API. So they're fixing that by putting like CRDs in front of it. So even if you were to have like a Helm 3 controller, right, it's the same pattern where like you have RBAC protecting you. But yeah, having a privileged component with a service account inside of the cluster is half that problem. And that is a trade-off if you want to do like the whole GitOps thing with the controller inside of the cluster. But I like where you're going, and I thought this too, is that perhaps we could build binaries that have a command line component such that they're usable in more like a CI push or like operator from your laptop fashion, so that you could invoke parts of the control loop as a command line binary, right? And then have like sensible logs, because your logs should be good anyway if the operator is running inside the cluster, and then you would just use your own service account as a cluster admin from your laptop. What do you think?
Yeah, I think that's something that is worth entertaining, right? But like, I don't know if there is a way to kind of think about the problem in a way that there's this component that that can switch between different roles, and it sort of ephemerally assumes role on the basis of something. I don't really know if there is such a thing, and if there is a potential direction that we could spin the whole service account thing towards, right? Honestly, I don't really know what I'm talking about. I'm just trying to imagine if there is a way to kind of avoid having to have all those the sort of the privileged level of access permanently, and sort of just like have to like make it somehow assume that level of access at certain stages when needed, not for the rest of the time. And
what you could do,
sort of ask for that level of access to be escalated and then drop to the later point. And I don't know if that's entirely possible in any way.
Yeah, we could make it so that like you could, I mean, you can reduce the amount of code that's running in privileged mode by like executing a job from the controller, but like it just makes it worse, I think, because we're adding so much code, right? Like
it does make it more complicated. Yeah, I guess I was like that. Say there is something that runs permanently, and then whenever it does have to make a change, it makes a call to something else, and something else decides whether it's authorized to make that change and should have that level of access. And then it does that, or something of that nature. But then yeah, again, it definitely becomes more complicated.
The service account like already is exactly what you said, like in that like it's getting authorization from the Kubernetes API, but yeah, you just can't get away from the problem, right? Like if you want it to be able to, this is a controller managing another controller, right? We have the operator managing core DNS, which needs to.
I think there are actually some really good ideas here. I think we should keep brainstorming them and looking into them. I think assume Rob, I don't know if we've actually. I think that is possible. Actually, I think like the CLI tool reminds me of is also sort of similar to pre-creation, and I think if maybe it's okay to just be able to read the service accounts but not write to them, and then we could also do our own authorizer I don't necessarily want to do that, but this is an RBAC limitation. I think one of the things I would like to keep is, one of the things that I like about operators is that they are able to monitor the ongoing health of things in a way that a CMI tool finds difficult. And I think, Jeff, do you want to talk a little bit about some of the status? You did a lot of the work on the status, right? Like, do you want to talk a little bit about that status reflection, which I think we should, whatever solution we do, I think we should have something like what Jeff has built for status.
Yeah, when I started down the status path, my goal is to get, basically, to the extent possible, a single sort of Boolean healthy value. What I want to be able to do is to write tools to scrape a cluster and say what aspects of this are healthy or what aspects, more importantly, are unhealthy, and then ideally, allow an operator or some sort of service to dig into that. So the sort of first implementation we have in the declarative library is a tool that will look through all of the sort of deployed objects that are related to that CR. So, you say you deploy core DNS, that kicks off a deployment, a service, a few other things, and it will go and fetch those objects and form a sort of an aggregate health based on that. So if the deployment is up to date and it's healthy, that's a true. If the service is in a bad, that's the endpoints aren't there or something, that's a false, and we can sort of aggregate those together and get like a final false value. And what I believe we have, I'm trying to separate the demo from what code got checked in. What I believe we had is sort of an error message at the end. We have the Boolean healthy, and then like a more detailed, like, okay, and this is the component I saw that was unhealthy. I think providing a way for providing a sort of basic foundation that just is like the aggregate Kubernetes stuff, and then additionally allowing the sort of domain-specific add-on authors to write these sort of ongoing checks, I think would be fantastic. Like, you could imagine a core DNS probe that is deployed as part of this, that is periodically making sure cluster DNS is working, or maybe it's working to a certain performance level. That's what I really want to make sure that we enable something along those lines.
So just paging back a little bit, is the assumption here that essentially when we consider a set of workloads, like a whole bunch of pods that belong to different controllers that represent a thing, and the health of that whole thing isn't necessarily represented by some sort of a sum of health of all the pods within that thing? Right, so we're just sort of saying that we really need something that is above that, because the health of individual pods may or may not mean some all the pods may be healthy within our thing, but then somehow the whole thing isn't quite healthy.
Mm-hmm.
Is that
I think that's a good way to put it, and I think that's sort of one aspect. And one of the challenges with add-ons is they really span multiple resource types. And besides component status, we don't really have a good aggregate sort of concept like that. And I think the status field on these sort of add-ons is a really good opportunity to build something like that, or sort of explore at least.
I think I've been thinking about this problem from a perspective of vCloud Agent. vCloud Agent comprises of a few things. I already kind of mentioned it in the doc earlier on, but sort of from this particular perspective, vCloud Agent has a few things. One is a scope daemon set that collects some data and sends it off to a remote service. And then there is the Prometheus bit that uses Prometheus remote write and also writes that to a remote service. And there's Flux as well, which monitors a Git repo, which is remote, and also reports back to the remote service. So it's like a SaaS. It's a collection of SaaS agents, right? And the health indicators can become very fuzzy. Like, should pods be unhealthy when they are not able to talk to the SaaS component, or how they should manifest that, right? And how, as a user, should I be able to determine whether this whole collection of agents in a reasonably healthy state or not? At the moment, user kind of has to go into logs of some of these things, or look at the SaaS UI to determine whether those things are good or not. There's no way to kind of arrive at a cluster and say, hey, are all the vCloud agents healthy or not? Oh, no, you have to look in vCloud, the SaaS service, and kind of tell that otherwise. And that's one perspective that's out there thinking about some of these problems. And I think maybe an important use case for other add-ons that are to do with SaaS. But broadly, of course, it's probably also quite important to everything else.
Yeah, what's interesting is like a lot of the problems we're facing are just general Kubernetes problems. They're just extra important to us because we're really concerned about them as the core parts of the cluster. And I don't want to go too far down the we're going to create the most generic application management thing in the world. But I do think that this is just such a good use case to explore and sort of solve these sorts of problems in a real targeted way to make this sort of stuff easier. And I think there's a lot of areas we can leverage or learn from in that space. So I'm definitely interested in that.
Justin, were you sort of done with presenting?
Yeah, I'm done with presenting. I was hoping, yes, it was intended to kick off a conversation. We've definitely kicked it off. I don't know if there's any other. I hit the points I wanted to talk about on the PR. So,
cool. Yeah, I'd love to take the floor a little bit. Also, Jeff, I really like the idea of having a status controller. One interesting thing that ties back to the nuances of the RBAC conversation is that the status controller for the add-on CRD, it can be less privileged and run separately. So that is a thing, since you probably don't need to even be able to update stuff except for the CRD. And then I did poke around at Operator SDK and kind of have some Hello World style code that makes a CRD compliant with the KEP, similar to Justin's strawman. And then it just spews a bunch of resources. It's not really consumable at the moment.
I just want to set the ground. I don't think you have to be compatible with the KEP. If you want to do the best thing for the Operator SDK.
Yes. Yeah, I threw in a version thing in there, and then I have a placeholder for that string field for the core file, and I have some ideas of kind of with what Ilya was talking about. Personally, I don't think that an add-on is very useful if the application's configuration is not extensible in a way that the operator has control over. And what I mean by the operator is the cluster admin. Because I've personally had to modify core files pretty extensively to operate clusters in bare metal environments with interesting DNS and service discovery setups.
Is that limited to the core file, or is that also memory on the pods, for example? Or
I mean, things like resources you would hope are usable. Also, I noticed the add-on directory has a node local DNS cache version of core DNS. I started reading that, and there's some pretty interesting configuration options. It's a completely different deployment topology. So these are interesting things to think about. That deployment is so different. I think it could just be its own operator. But there are simpler use cases that I think the single deployment core DNS operator would need to be able to accommodate, extending the config in order to have feature parity with what we're doing right now with tools like kubeadm, right? Which is just exposing config maps and stuff like that to people. Because if the operator is now going to control the lifecycle of those resources, then you don't want to get into a space like Prometheus operator where core DNS, adds some flags, and then we need to update our CRD so that people can actually use them. But then that doesn't happen for 2 releases of Kubernetes. Right? Also, yeah, if we're really gonna write a CRD over the core file, then we need to be able to have people append random strings to things. One thing that's really cool about the approach of the operator potentially being able to manage the config is that we can pre-validate it, and without even like doing a rollout if we want. Although we'd have to vendor core DNS libraries. So I've been turning on that idea. The operator SDK project is interesting. One component that's a little strange to me is that they have this operator lifecycle manager thing, which seems like kind of a fat thing to just like imply that people should install. It also feels very OpenShifty. I'm not educated on the like total context of why these components exist yet, and like I'm not mature in my adoption of this framework. So if people are on the call that know operator SDK like really well, really like to discuss. Does anybody know what that lifecycle management component's value really provides? It looks like it does some templating.
Hey, I can help with that some. Mostly just so Operator SDK is not tied to OLM in any way. Operator SDK is essentially like an alternate kube builder implementation, and there are like discussions around like how those things will align going forward. One thing it does do is generate additional integration with OLM if you are using OLM. So that's the value there. And then OLM itself is all about keeping a set of operators installed in a consistent state, up to date with their dependencies. So if you're dealing with a single operator at a time, like if you're just playing with core DNS, there's not a lot of value from OLM. But when you have like 10 operators with interdependencies and they all rely on different CRD API versions and things like that, that's what OLM is trying to do.
That sounds really applicable to the kind of problem that we're really trying to solve, which is creating a level playing field for people to, publish and distribute their applications in a way that can be standard managed by the installation tools.
I think the goals are pretty aligned for sure. I definitely see whatever comes out of these general discussions. I see us aligning with that for OLM as well, for sure. That's why I'm saying it.
And do you think OLM could work for operators that are not built using the operator SDK?
Yeah, absolutely. In fact, the majority of the operators that we run with it are not built with the SDK.
That's really cool. I'd love to. Yeah, I don't know if you're willing to sign up for anything, but maybe next time we could see like you could do a little walkthrough or demo or something of what it actually would do for when we have more than one operator with us.
Really do that, and I can talk about like where we might want to evolve it in the future and get more feedback from the needs from this group and that sort of thing.
Yeah, there was also like a hub or store type thing as well, right?
Sorry, what was the question?
It was like a discovery component to it as well, where anybody could go. I forgot what was it, operator hub or operator store or something of that sort.
Yeah, there is. So that's actually a separate component. So by default, OLM deals with local sources of data, very much like you get like an apt repo or a yum repo locally on a machine to install stuff. There's also a way to pull in manifests from external and pull them back into a local store as well. But they're separate components.
Yeah, no, I was thinking of like something like operatorhub.com or something like that, where you go and find the list of all the things.
Yeah, Operator Hub IO. That's our community project where people can bring their community content and make it available there.
Jessica, does Operator Hub interact with OLM?
Yes.
So there's two Operator Hubs. So there's Operator Hub IO, the community project and place that you can go and you can find all these things. And when you go there, you can get kube control commands that let you just install these things to your cluster. It doesn't matter what kind of kube cluster it is. There's then what we call embedded Operator Hub, and that's where you install a local Operator Hub instance onto a Kubernetes cluster. And that knows how to reach out and get content from a registry.
Because the thing, right, like the value of what we're doing in wrapping these apps of many different objects with an operator and a bunch of RBAC, right, is now we have a shared interface. And so we need that, we can build around that abstraction. And it seems like the community and Red Hat have already put in work, to build some tools that work with a shared abstraction. Like if these tools are installing operators and managing their RBAC, and then like they've got CRDs and people can use kubectl to see what's in the cluster, then like that's a lot of problem that's a solution. That's really valuable. We could probably move on from that topic since we spent a couple minutes on it, unless anybody has other comments.
Well, Lee, I don't know if you want to submit your, it'd be great to be able to look at the code that you've written or see an operator SDK example. I don't know if you want to submit it as a PR, like the same thing I did with, like, I think that would be helpful to sort of like get the best of both ideas and see whether, there's a solution for the RBAC problem. Sounds like local operator hub might have solved the RBAC problem somehow. I don't know. Or the tiller RBAC problem.
It doesn't really solve the general RBAC problem of the operator needing to have a superset of the permissions of the thing that it operates. Okay. That's definitely still, to me, that falls more in line with like maybe some of what the policy working group is looking at.
Okay.
But yeah, I'm aiming to submit that patch. There's something wrong with my reconcile loop.
Yeah, I'd say, Justin, that some of the stuff it does give us. So OLM, for example, is the one that is actually going and creating the CRDs on the cluster. So your operator then doesn't have to have the required permissions to create CRDs.
Yeah, I think that makes sense. I think I think the kube builder assumes that some other process creates the CRDs. Typically, it doesn't really do CRD self-registration, which does seem like a generally bad idea in terms of RBAC permissions.
And I do think that you could build some powerful library that wraps a controller with some command line features so that it's useful to people who do not want to run these privileged components. Because if you're running it temporarily on a laptop that has access to the Kubernetes API, all of the storage is in the API server. And basically, you have that temporary credential for somebody to do whatever they want, right? But, cool. The next thing I wanted to just chat about is, like, to me, I want to like reduce the number of like binaries that I'm deploying to my cluster and increase like cache hits for images. So if we want to have a persistent management component, it's useful to have like one thing that can do generic stuff with a bundle of stuff from some packaging format. So like Helm and Tiller is a great example of the concept, not a great example of like a technical implementation for many reasons that are being fixed. We need a packaging format, and we need it to be extensible for users to be able to like patch stuff, provide options, provide ways for those packages to consume options, like normal packaging things. And then we just need something to babysit the runtime of that stuff, which is the unique part. So Flux already does this pretty well. Sorry, there's applause. Hopefully you can. Were you guys able to hear the clapping? Yeah. So Weaveworks Flux has a very large community, and it's an operator that runs in your cluster that can maintain collections of things that come from a Git repo or any number of packaging formats. We have an integration with the Helm release CRD that's implemented by Weaveworks Helm operator. And these are, long-running daemons in the cluster that manage stuff in the way that we are generally talking about. And I think that there's maybe some simple work that we could do to build an integration and maybe a generic application CRD potentially that exposes values to people and allows them to even put like maybe specify, hey, take this application bundle and then also like apply these customize patches from my own Git repo, right? It's like, that's a really sophisticated story. It's moving beyond like installing the defaults and actually enabling people to use those existing patterns with like healthy operations, like, and they don't have to like fork the operator and maintain a bunch of Golang. So it's like, if you had something generic that could apply a bunch of customized directories, you know, to a cluster and then babysit that stuff and report status back, you know, in some general way, you could build a pretty powerful abstraction that you could then restrict and install multiple times, or have a cluster operator or whatever. I'm curious if anyone has thoughts.
I mean, I think we discussed and we prototyped, I think, or Jeff prototyped allowing patches in the CRD instance. So in this case, the core DNS CRD instance, you could actually put a customized patch or a kubectl patch in that instance. And so if you wanted to change the memory and we hadn't exposed that, you could have a patch that patch those resources. I think that's, you also, I think there's two areas of customization you mentioned. You mentioned that sort of customization of for one add-on, how do we do additional customizations? And then I think you're also hinting at the idea of sort of the general, like a generic operator, which, so instead of having a core DNS thing, we would have a thing CRD or an add-on CRD, which would have a manifest, which could be patched, right? To me, I think that it's not a lot of work to create these operators. Once we have all the like tooling in place, they're not particularly heavy if we put them into one binary. So you can combine them into one binary, and that's an area where the machinery that we talked about previously doesn't necessarily help us. So that's an interesting data point there. But the advantage in my mind of having the separate core DNS CRDs is that it's very, a core DNS CRD and a kubeproxy CRD, for example, is it's very explicit what you're getting and what you're doing. And I think the advantage of having separate code is that I sort of see this world where, like, as time progresses, every controller starts simple and then becomes more complicated. So, you know, maybe core DNS, we have to do some complicated migration at some stage. Like maybe we move to core DNS v5 or whatever it is, and there's something fancy we have to do. We can do that because we have code. We can always like burst the bubble and do whatever we want. Whereas it's sort of hard if you're in a generic system to do that. So I hope if we can make the cost low enough that we can encourage everyone to just build specific types, but I think it's definitely a valid.
Yeah, I echo what Justin, you're saying right there. That's exactly our thinking as well. If you start out with an operator for an application you're trying to build around, you can grow into whatever operational needs you have over time, whether that's migration or automated scaling or whatever it might be.
More sophisticated status checks or whatever, yes.
Yeah, whatever your heart desires in the future, you can do, and you've already got that framework to put it into.
But I think it's a very valid and important point. So thank you, Leah, because it's like, it is a fundamental difference between this and something like, I guess, like the Helm family, where it is a generic tool, right?
Yeah, I'm interested in kind of what you're talking about with like a core add-on controller manager, right? Which is having a single binary with all of the control loops for the different add-ons. But that would get a little gnarly with the RBAC thing, right?
The RBAC thing becomes very uncomfortable at that point, yes.
Yes. And then you have the same problem, you know, with like even a generic code base or generic binary that you have to deploy multiple times in order to get the granularity of RBAC that's appropriate.
Yeah, I definitely think we should all think about RBAC and see if anyone has any great ideas next time we meet, because it would be great to fix that. Someone said there was a policy working group working on this. I'm not familiar with their work.
I'm not familiar with their work either, but it seems like a policy issue in Kubernetes, and I know that there is a policy working group. That's the extent of my knowledge.
Okay, thank you.
I mean, if something has a path to perform an escalated action, I mean, it's, unless you can somehow, like, I guess you could, you know what you could do is you could do RPC through a CRD and then use RBAC to change fields on the CRD that another controller would pick up. That would be an RBAC way to do privilege escalation in an RPC format, because then you'd be limiting what the thing can actually do, and the code is somewhere else running privileged. But I don't actually see how that's really more safe than a statically compiled Golang binary with the service account just always ready to go. So, yeah.
There's definitely an element of trust you have to have for the concept of operators in general. And one thing that's not easy to solve right now is something like, I want this operator to be installed with this level of permission, except if it hits this particular problem, I don't want it to try and reconcile it because that would require XYZ permission that I don't really want to grant. So like, this is kind of a hard problem that we have with the current RBAC systems in general, which is it's kind of hard to come up with a functioning operator that has less than the normal amount of permissions that it generally requires to do its job. But it's a really interesting problem. I'm not sure it's something we can solve just in this room. It seems like a larger RBAC/policy discussion for sure.
Anyway, we hit all my discussion points, so I appreciate people sharing their thoughts. And then I'll
really
push
great
that
discussion. It's been really great. Thank you, everyone. I wanted to say, yeah, and like, I'm excited about the RBAC thing. I'm glad to hear that other people are also grappling with it, and that sounds like something we definitely can figure out together.
Is anyone like super confused in what I said about like using a CRD for RPC to escalate privileges to other code, or to perform action in privileged code?
I think I know what you mean, but I think the challenge is going to be, how do you decide whether that RPC is permitted or not, right? Right. So we basically have another super process, but how do I know whether that request is actually a good request or not? Like,
well, because I mean, it's all through the CRD, and then the component had the privilege to modify the field.
I'll have to think about that some more.
I don't see how valuable it really is, because you just have to have privileged code running somewhere else in your cluster. So,
I mean,
or you could have
is valuable, but
the authorization, yeah. Anyway.
Yeah, do you mean that like I have a bunch of RPC calls that are all represented by a separate CRD, and the ability to create that CRD is equivalent to having permission to do the privileged action?
Exactly, right. But then only a very specific niche of privileged action.
But
and
then you think that's watching those to perform the privileged action still needs...
Exactly, yeah.
So,
yeah. So it's like, it doesn't really help, except that thing could be running in a different namespace or whatever. Which, if you didn't want a service account in a namespace where the application is running to exist that can actually manage the app, then you could do.
Well, I would say that's true of operators in general. It can be really useful to run the operator in one namespace and configure it to watch one other namespace instead, just to get that separation.
Yeah. Yeah.
Yeah, we only have a couple of minutes left. What do we want to do until the next meeting in 2 weeks? Lee, you wanted to push some code to speed up? Great. And the suggestion of doing the OLM demo, is that something you want to do next meeting?
Yeah, we can do that.
Cool. Yeah, thanks a lot, Justin, for putting this together.
Thank you for letting me show it, and all the good questions. Great. And I'm going to try to think about RBAC some more. RBAC is, yes, we can solve RBAC, we'll be very happy.
Right. All right. I'm going to post the video in a couple of minutes.
Cool.
Thanks a lot, everyone.
Thank you.
See you in 2 weeks.
Bye. Thank
Bye.
you. Bye.